Hey, P-Stat students, Mr. Mitchell here. We're going to take a look at sampling distributions for proportions today. We're going to take a look at note 7.2. I'm going to let you go through the rest of the notes, okay? And we're going to look at one question together. It's basically a start to finish product of what you're going to be asked to do mathematically. There's other pieces to it, but this is kind of everything in a nutshell in all one swoop. So the Gallup poll asked a simple random sample of 1,785 adults whether they attended church during the past week. Let P hat be the proportion of people in the sample who attended church. A newspaper report claims that 40% of all US adults went to church last week. Suppose the claim is true. Of the poll respondents, 44% said they did not attend church last week. Okay, so the poll said 44%. All right. Find the probability of obtaining a sample of 1,785 adults in which 44% or more say they went to church if the newspaper's claim is true. So we assume the newspaper is true, but we have this poll that said 44%. Does the poll provide convincing evidence against the claim? Okay, so we got some things that we're going to need to find here. All right, we got to find a mean, we got to find a standard deviation, because think we got to do some kind of a z-score. Okay, how do I know that? Well, looking at it, what else would we do? Remember, we talked about some different things with probability. There's 6 things. I don't think we can do a counting method. It's not geometric. I don't think formulas A or B, A given B, are going to be helpful here. I don't think a tree diagram is going to work. So could you do it with binomial? I'm sure you could. But the fact that the sample size is so large, that's why I want to do it as approximately normal. Okay. If you were going to do it with binomial, really what you would have to do is take 44% of this number, and then whatever that number is, you'd have to do that number and everything bigger than it. That's a long problem. Okay. Or you can do binomial CDF. I'm sure that would work. But again, I think it's easier to do normal CDF. Less checks, less things that you really need to focus on. You still got to find mean and standard deviation, whether you do it with normal CDF or binomial. So some notation. If you don't know the notation, then don't use it. Just say that it's the mean. So it's the mean of P hat is really what we're trying to find. Okay. So the mean of P hat, which is also just P. All right. If you took many samples, it would equal the true population proportion. And in this case, that's 40%, but we're going to change it to a decimal. We're not going to deal with 40%. Okay. So we need to think about SOCs. I'm not really talking about outliers, but we need to think of the center, the shape, and the spread. We're thinking that it's normal CDF, so that's our shape. Here's our center, and then we're going to find our spread here in a minute. So before we find our standard deviation, we really need to check the 10% condition. All right. So is capital N greater than or equal to 10N? 10 lowercase n. So is the population of the US greater than 10 times 1,785? 17,850. You think there's more adults than that living in the United States? Yeah, I think so. We're definitely in the millions. So we're good. 10% condition, again, that's the independent check. That's the replacement versus non-replacement check. That allows me to find my standard deviation. Okay. So notation wise, I'm going to write it as the standard deviation of P hat. Okay. You don't remember the symbols. Okay. Just say standard deviation of the proportion, right? Remember we talked about don't use symbols if you don't know them. Okay. So to find the standard deviation of the proportion, there's a formula. Again, this formula is given to you, but it's P times 1 minus P over N. That's supposed to be a parenthesis. So I've got 0.4 times 0.6. These two numbers should add to 1. And then that's over 1,785. Okay. Just for time issues, I'm going to do some of the calculations on my own here. So if you multiply, divide, and then take the square root, that is 0.0116. Okay, so that's our standard deviation of our proportion, okay, of our sample proportion. Again, if you took many samples, this is what it would be. Okay, so our 10% condition has been checked, and we found our standard deviation. So we would like to do normal CDF. Okay, but we must meet the normal, approximately normal checks. So it's NP greater than or equal to 10. And then N1 minus P greater than or equal to 10. Got to meet both. Okay. So I got 1785 times 0.4. Pretty sure that's going to be bigger than or equal to 10. We're actually going to find what that number is. And then over here, 1785 times 0.6 greater than or equal to 10. So when I multiply that times that, what do I get? 714. Multiply those out. Good. And then if you multiply that out, what's that? 1,071. I think I did my math right there in my head. That's greater than or equal to 0, or greater than or equal to 10, I'm sorry. Okay. So we are good. So both are at least 10. So we can say that the shape of the distribution is approximately normal by large counts. All right, so we're on our way. All right, so we can do a z-score formula. So we're going to do it both ways just so we can practice. And then I will get the calculator out to show you how to do normal CDF. So what we're trying to find, and this is helpful to either draw a picture or to do it with symbols. We're trying to find the probability that p hat is greater than or equal to 0.44. That's really what our question is. So to do that, remember our standardized z-score is always a number minus the mean over the standard deviation. So that number is p hat minus the mean over the standard deviation that's all inside the square root, by the way. Okay, so there's what our formula really looks like if you're going to do it with a formula. If I want to draw a picture, which is very helpful, so I don't have to show my work very much, 0.4 is here, 0.44 is here, and we're trying to find this area this way. Okay, so this would be mu sub p hat, or p. And then this is p hat over here. All right, so drawing the picture, that's kind of what the picture looks like. So if I'm plugging in my numbers, this is 0.44 minus 0.4 all over my standard deviation of 0.0, all right there is 0.116. So you calculate, that's going to be 3.45. So then I look that number up in the table. And since it is a greater than, then I got to do 1 minus that. So I'm going to kind of stop there with the z-score process. And now I'm going to go into the normal CDF concept. Okay, so it's really the same thing. Most of you are probably going to do normal CDF. So I got normal CDF. So I got my lower bound. That's going to be 0.44. I got my upper bound of something big. How big? It doesn't really matter. Do a bunch of 9s. My mean, which is 0.4. And then my standard deviation, 0.116. Don't forget to label your information there. Okay. So here's my lower bound. And again, you should write these out for AP test. All right. I know maybe I should make you do it all the time for practice. This is my proportion P, or you can call it mu sub P hat. That works too. All right. They are essentially the same thing. And then here's my standard deviation. You can just call it sigma p hat. That works. Okay, or just write it out in words. Okay, the words are always good. So let's go to our calculator here. Let me bring that over here. So we're going to do second distribution. We're going to do normal CDF. We're going to have a lower bound of 0.44. We're going to have an upper bound of something big. Doesn't matter how big. Our mean is 0.4. Our standard deviation is 0.0116. Right? 0.0116. Yeah, I just want to make sure. So then I paste it and I calculate it. And it is very, very small. So 2.8 e to the fourth. So that's 2.8. That's 0, 0, 0. Come on, 0, 2, 8. That's our probability. That's approximately our probability. Okay. It's not very likely to happen. So we found our answer. Go back to the top. What is the question asking? So find the probability. Okay, I did that. I found the probability. It's not very likely, but I found the probability. The newspaper's claim is true. Does the poll provide convincing evidence against this claim? So remember, anytime this is less than 5%, especially if it's less than 1%, we have evidence against, got the S, against the claim. And for time purposes, for you and for me, when we're in practice, again, I should probably make, I'm going to write it out just because we need to get in the habit of doing it. We have evidence against the claim that the proportion of church, I forgot a word in there, against the claim that the population proportion of churchgoers can't write today. Population of churchgoers last week was not 0.4. Right? The claim, and some of this writing is not very good, and I apologize for that. So we have, the claim is that it's 0.4. Last week, the claim was that it was 0.4. Okay? Maybe that's typically what, it's about 40% that people go to church. I don't know. But let's say it is 0.4. Well, this week we found a sample proportion that said it was 44%. So that's only 4% off, but that's 4% can be a big deal. Okay. So what's our probability say? Well, the 44% wasn't very likely. 44% or anything larger wasn't very likely. So that is evidence against this claim that it was 40%. Okay. It doesn't prove it. It doesn't guarantee it. It's evidence. We're in the business of providing evidence, and then eventually we can prove things beyond a reasonable doubt. But we're providing evidence. We're not the jury, if you will. We're kind of the police, we're the detectives. We're finding the information, the evidence to then show maybe later of the proof. Okay. So that's the start to finish. We can't do this if these checks don't work. Okay. You can't do normal CDF if these checks don't work. And we can't find standard deviation if this check doesn't work. Well, if we can't find the standard deviation, then we can't do normal CDF either. Okay. Or Z-score formula, either way. So really, these are the checks that have to be true. There's another check that we kind of assumed, and I'm just going to talk about it. We need to make sure that an SRS happened. The data must be randomly collected. So that is another check that we will hang our hat on as we move forward. Okay, so don't forget that as well. Again, that's your bias piece. And without the SRS, really, this isn't true. Okay. So when you have an SRS, then you can go with this. And then once you can go with this, then you do the 10% condition to find standard deviation. It kind of flows from one thing to the next. Okay. Let me know if you have any questions, and I'll see you next time.